Hello, I'm back here with a new video on Three.js, and this tutorial will be on an immersive experience because we want to learn how to take a virtual tour in an art gallery. Since we made another video on Three.js art gallery, but it can be anything like an hotel, an apartment, or a tourist attraction, such an historical or archaeological site. So we need several things to achieve this, but among other things, that of course we need a good 3D model, good scan. A useful trick to achieve this is to play with camera movement and camera animation. Okay, and that is what we are going to do in this video. We will play with cameras. We want to guide the users to show them the places that we want to show. Okay, because we enter the hall or the gallery or the hotel, we want, when he moves the mouse or he clicks, we want to show him the place around, the products that we have, or anything. Or for example, we can make it interactive later. I click or I zoom in a painting, or in something that we might have there. I click and it shows information about the painting, who is the author, the description, etc., etc. Or in an archaeological site, we can make this guided tour, and when we click, we can show more information for the user. Like, for example, the project of Harvard University with Giza pyramids. They have a very beautiful project. I have another video on my channel about this. And this kind of project, you enter the pyramid of Giza, and in a guided mode, they show you the place, the pyramid with information, the history, etc., etc., etc. Okay, something like this. This is the idea. This is why I wanted to make this tutorial. Uh, there is another tutorial about this, and yeah, I saw this guy. I actually am subscribed to him. He makes some tutorials about Three.js. I forgot the name at the moment, but yeah, I will mention it in the description maybe, because yeah, I like him. He makes very good tutorials on Three.js. The only thing is that they are very short, and usually Three.js tutorials are very, very short, like 4 minutes, 5 minutes, at maximum 10 minutes. Or there are a lot of projects, but they are just a showcase, it's not really from scratch and guided, etc. So I thought, why not create something from scratch for the beginners? Maybe it's easy to follow and they can use this for their own interest. Okay, this is because with Three.js there aren't a lot of from scratch, but there are some guys that they are very great in YouTubers to for these videos. I follow them. Maybe I can recommend you these guys because they have some very nice videos on Three.js. But yeah, I think they are very, very advanced guys, so maybe they don't have the time, of course, to stop and explain everything. I can understand them. Also, there is Bruno Simon that has an amazing course. I learned at the beginning Three.js from him. I learned a lot from him, and I always have him like some kind of reference when I need to something. He's great, but yeah, he doesn't have. Sorry for my English. He doesn't have many tutorials on YouTube. Like he has his course on his page, but he's a great uh, instructor. Yeah, let's take a look at this project that I was talking about. The user enters the hall or the gallery or what it is, and we want to guide him to show the place around. Okay, maybe later we can add the interactivity to click in the places or the product or the painting, depending on the project, and we show the description and information, etc. But here we want to show him with camera movement. I enter this, I click or move the mouse, we move the user here, we show the place, we fly it with the camera in a different place to show him around. Okay, yeah, and this model is very beautiful, by the way. Is the royal house uh, in Sweden, Stockholm. I forgot the name of the museum, but I will add it in the description. The page where I will show you here, maybe because yeah, you need to download it. Given the credits, of course, always given the credits. Yeah, pretty much this is the project. Uh, we will learn this trick of moving the camera around uh, using the controls, the mouse. But without wasting time, let's start. We will start from scratch, of course, as always, but I will not stop in details with some concepts that we have it in my other videos. So I'm not going to explain maybe in detail, but I think I will explain, but not in detail. I will also leave comments as usual, but I will not stop in depth. If you want maybe to take a look and go in detail, you can watch the other videos. They are like always the same things, at least for the most important concepts and the usual classes that we use in Three.js. So let's create the project. As usual, we window plus R, write cmd in the window, open the terminal, go in the desktop, cd desktop, create a folder for our project, mkdir, let's call it, I don't know, camera, camera, animation, or not just camera, just camera. Go into this folder, cd camera. Okay, let's open it with our VS Code that I will always say it and repeat it that it's the best editor, but you can use the editor of your choice. Code that. Okay, camera, this is my project. I will add the server to this because you can use the server. You can use the server for your needs, for your projects. So I will also add the project, but I will not stop to explain the server side, but you can use it maybe in another video. Okay. So I have it here, the folder of Webpack. I will just add some folders here and we'll install, the libraries that we need. Okay. We have it. We have the bundler and the static that we need the static to add the models or the textures, etc. So let's create a model folder here. in the static. We need an src folder, the usual src to put the folder about JS, etc. src. Uh, what else? So we need, yeah, the usual HTML and JS, etc., etc. Okay, and later we will create the scene with everything that we need. But when you download the project from my GitHub repository, the first thing you should do is open the terminal here. Open the terminal in VS Code and run npm I. npm I will install all the node modules. So all the dependencies that we need for this project. And what are the dependencies, or what are these, external libraries that we have? You can take a look at the package JSON. Every time you download a project from GitHub or when you work with someone, because we never uh, upload node modules on GitHub because they are very, very heavy. Yeah, and it's no point to download node modules on GitHub, because you can download the project from GitHub and run npm I. It will install all these dependencies and you have their node modules. Okay, so there is no point to download. Not you never do it because it's very, very heavy. It's like a black hole have here, these node modules. And these are the dependencies here. In the package JSON, you can take a look like Bubble, it's compiling, etc. Some other libraries, Webpack, some other that no need to mention now. So run an npm I, you install all these dependencies. And you are good to go. You can run a simple command, npm run dev, and with npm run dev, you run the server. npm run dev, and that's it. Simple as that. You run the server on your local host. You will have here an URL, an IP address that you can click on it. When it's ready, it will show here localhost 8080 and another IP address. So use either one of those links. Just okay, project running at one of these two here. Okay, and here we are. Okay, so many pages, child failed, etc., etc. Too much error since the beginning. Okay, we don't have any index HTML, we don't have anything yet. Let's create the HTML. Index HTML. Okay, index HTML. Something else, we need the CSS part and also the script for this. So script, HTML, CSS, the usual things that you have. Okay. Let's put this in our SRC. In SRC, let's create the script JS. And yes, very basic SCSS, just to remove, margins, paddings, etc. Because with Three.js we don't need those by default styles. Style.css. Okay. Meanwhile, Webpack with 2 arrows. Let's run basic template. HTML, change the title, camera or 3D tour. Okay, 3D tour. Just the basic styles. You can skip this if you want. Just margin padding 0 and some very basic. For example, we don't want the scrolling overflow hidden. What else? We need for the canvas, canvas position fixed. Okay, and that's it. And we can start. Unable to locate users, desktop, camera, static. Camera, static. Globe. Yeah, because we have the static folder empty and it gives you an error when you have empty the static folder here, or have empty folders, or you want to add on GitHub. When you want to add some projects on GitHub, don't do it with empty folders, but to overcome this you can add that git keep file. I think it should be okay now with this git keep empty file. Let's check. Yes, no errors. No errors. Okay. Uh, Git keep doesn't mean anything actually. It's just an empty file, and the name I think they used to give this name git keep because usually when they create this empty file when they want to push to GitHub empty folders, but I don't think it means anything. It's just to create an empty file. Okay. So we have our node modules, and inside node modules we should have the three folder. Okay, just to find, okay, here, three folder with this everything. So to import these three, usually we do import asterisk as 3 from 3. So import everything from 3. Okay, and this will be our main object, our main class. We will access every class inside 3 object with this 3 here, and asterisk 6 to import everything there. Okay, we will also need something else For the controls are not inside we need the exact path for the controls, and that is import curly brackets to import a specific class, in this case orbit controls. Don't worry about this. If you don't know, we will use it later and you will understand. For now, just don't care. The path for this is from examples from 3, and then examples, yes, JSM, okay, JSM, controls, yes, controls, JSM controls, yes, should be orbit controls, okay, we have it. Something else, we will need the GLTF loader. Again, don't worry about this now, what it is and what it is not. We will use it later, you will understand. But yeah, this is just to load the model. GLTF from, again, this is from 3 examples. JSM again, but not controls, but loader. Loader, there is no loader. There's no loader, yes, loaders. And GLTF loader. Okay, this is going to. What else we need? Yeah, we might need a debugger configurator. A configurator is to add in our UI a configurator so we can trick the parameters. For example, we want to move something. It's pretty hard to do it, with calculations there and check and do calculation and check, move it. So for some parameters, we can do it in real time. Like, you have it in our 3D softwares. We always have some configurator UI to change the colors, to change the sizes, etc., etc. in real time. We can do it with Three.js. I think maybe we will need it. So import as lead GUI from lead GUI. I don't know if I installed this one, but I should check. Do we have the GUI here? Okay, yeah, I put it in the template. What else? We don't need anything else for now. We can start to create the scene, but first of all, let's add here the canvas element, and for that, a canvas element with a class canvas. Did I give here in the styles? Yes, I gave canvas class. So canvas element with a canvas class. For that, a quick shortcut would be dot canvas. We want to create the canvas element, and dot again canvas. So we create canvas. Okay, I did no need to do it 2 times. But yeah, we created not the div. I'm wrong. Okay, you see, to create a div with a class, it's you just dot and then canvas. You create a div with the class name, but I don't want a div, so not dot and the class name, but the name of the element, in this case canvas dot, and here you can put the name of the class, so canvas dot canvas. So here we have the canvas element for the beginners that don't know this trick. For the others that already know, bear with me, don't laugh at me with these tricks, but yeah, someone might need it. We have a canvas, so we can start now creating the basic scene. For the basic scene, canvas. For the canvas, we create a variable that's a constant because we are not going to change this. So const canvas equal new, not new. We are not instantiating here, but we are just give the reference to our DOM element here. Okay, so with JavaScript, this has nothing to do with Three.js. It's just JavaScript DOM manipulation. So document query selector, you already know, I think, and grab the class name. That's canvas, right? Canvas. It's heavy raining outside, the perfect time to make a tutorial. Okay, scene. Now let's create the scene. For the scene, we instantiate from the class scene in this case. Okay, so create a variable, a constant scene new, because we are calling the constructor of that class, and that class is the class of scene that is from the main object 3. So the main object 3 contains everything, and we will access this 3 and then the class, which is scene parentheses. Okay, we created the scene and that's it. The camera, we create a camera, and the camera that we need, it's a perspective camera. We need the perspective camera. There are other cameras like orthographic, etc., etc. We are not going to talk about it. I talk in my other tutorial on 3D art gallery. We are going to use the perspective here. Again, a constant, a variable called camera. Again, we call new from calling the constructor of the camera, perspective camera, new 3 main object, and here we can access the class inside this object, perspective camera. Okay, and again parentheses. The difference here is with the scene is that the camera, we put some parameters, okay, that we need, of course, and these parameters are, I will always repeat it, you know, in every tutorial, because these are, let's say, important things. I will not go into much detail, but briefly, the first parameter is the field of view, and let's say 45 is okay, or 55, or you know, it's okay, the field of view. Okay, the second parameter is the aspect ratio. The aspect to save this aspect ratio when the camera sees something in the scene. And the aspect ratio is width divided by height. Width of the scene or the window. We have the window, accessing the window of the browser. So window, and the width of the window is inner width, it's the name, divided by window, again, inner height, as you guessed it. And this is aspect ratio. Okay, a comma here, always a comma between. Field of view, aspect ratio, and we have 2 other parameters, and the other is the near, okay, the angle for the near. I'm not going to stop here, you can watch the other videos, but yeah, the near, the angle for the near and the angle for the far. And usually we can give 0.1 for the near, you know, just the minimal, and 100 or 1000 for the far. Just an error because the comma here. Okay, and the camera is created, but always you need to give a position to the camera in the z-axis to just to pull it back some units, because you cannot see if you are very close to the scene. So you are, here's the scene, here's the camera in the, you know, in the zero value of the z-axis, so you cannot see anything, of course. So you just need to have the scene just a little bit. So give a value to the position of z-axis, which is the forward and the back, so the depth axis. Camera dot position dot z, just pull it a little back, 3, 4, 5, you know, and the value of 5. Move it back. Okay, usually we add the camera to the scene, or we add it with a render. You can see later, but yeah, usually when we create something, we add it to the scene. For example, scene.add camera, etc. The camera you add it with a render, but yeah, you when you create something in the scene, you add it to the scene. And yeah, we talked about the render, so we need the render now. The render is what has also the render inside. The render is the screenshot. You know, you have the camera, you have the scene, and you need to take a screenshot of that scene with a camera. Okay, and you access this render class with the renderer. You will see it now. It's just playing with words. For the renderer, we access this class of WebGL renderer. So again, a variable, call it renderer, usually renderer, okay. Renderer, new, again, always new. When you want to instantiate something from the class of, you know, you type the keyword new instance of that class, new instance. That class has a constructor that has, for example, some properties inside, you know, has some everything that have variables, methods, functions, etc. Has some values inside. For example, this dot color, and when you instantiate and put the color as a parameter, this dot color with this will be this object, the object that you are creating. Anyway, I'm not going to confuse anyone that has no knowledge of object-oriented programming, so I'm not going to stop. Just think about it: new instance, new object, new camera, new render, new anything. So render we said is the always from 3, because everything is from 3, and this WebGL render, not WebGL1, WebGL with uppercase render. Okay, this one, WebGL render. This WebGL renderer, that is our render, has an object side. This object can be empty, and it will create the canvas itself when we do then later render that DOM element. But we created the canvas here, so in this case we pass the canvas. So canvas, no, just key value, canvas is the canvas. What else? But to the render we set the size of it. Render.setSize. Set size is Is it correct? Yes. Set size. Again, we give the window inner width and the window inner height. Dot inner width and second parameter window inner height. This is, the size will be from the window width and height. Inner height. Okay, and this is gone. What else? We have this. We may put an object that, just a default cube. Usually it's a default cube, but I don't need the cube or any other geometry. I'm not going to create geometries like we did in the other tutorials, because in this case I'm going to import a whole scene, our royal family house. Okay, so we will not create any kind of geometry or material or texture or particles like we did in our previous tutorials. We are not going to do any of that. Okay, so if you want to know how to create geometries, materials, textures, check the other videos on my channel. In this, we are going to import a model, the scene that we saw at the beginning of the video, and then we will play with the camera. This is our tutorial for this video. But here I will need also the controls, because we will need these controls. You will see why, not just to move around, but we want to get the exact values of, where to move the camera and animate the camera. And it's very hard to get, exact movement on the camera in the scene with writing down the code and checking and debugging, etc. So we will use another method that you will see. For the orbit controls, again, create a variable controls, simple as that. This variable is a new instance, again, from the class taken from 3, that is called orbit controls. Orbit controls, parentheses, and this orbit controls has 2 parameters that we will pass. The first is the camera, the second is the canvas. Okay, and this is what we imported at the beginning, that I told you that we will see it later. So these are for the controls, just the movement in the camera. When we have a model in the scene, we want these orbit controls to, to immersive in the scene. We can add another property to this, and it is called enable dumping. Enable dumping, is it correct? Enable dumping equal to true. Yes, I think it's correct. Enable jumping. Enable jumping, not, is to give a sense of weight to the movement, and just don't worry about this, just to give some sense of weight. Enable jumping true. Okay, what else? Oh, we need the configurator. The configurator, for the debugger. For the camera, we might need it. And for that is a little GUI from little GUI. Okay. Simple as that. Const little GUI equal new instance of just GUI. Why not? Like this. New instance of little GUI.GUI. GUI.GUI. Okay, and parentheses. parentheses, and this is done. We are just creating here, but to use it we can see later how we can use this configurator. And oh yeah, of course we need the GLTF loader. Okay, I'm not showing you the scene because we don't have anything now. It just WebGL render list is not a constructor. WebGL render list. Why I would render list? Render list. Oh, oh, render list. It's WebGL renderer, right? It's just an error. I went for it. So we don't have anything here. What's again? File import module for orbit controls is not a constructor. Orbit controls. Where is it? Where is it? Oh yeah, it's not a constructor because we are as I said, new calls the constructor of that class usually. Okay, when you type new, you call the constructor of a class, and that class is orbit controls. This error here says that orbit controls is not a constructor at, you know, but this means that is not a constructor of this three. It like recognize it like it's that the constructor of them. So it's orbit controls because when we import like this with curly brackets and the exact path, we don't need the three. We imported everything as three here, so we access all the classes from these three. But when we put the curly brackets and the exact path, we can access directly that one. We are not accessing here from three. So that's why the error. And that is gone. Right, yes, it's gone. And we can also see this configurator just empty, but we can see. Yeah, we need the GLTF loader. GLTF loader. GLTF loader is very important in this tutorial because with GLTF loader we are going to get the model, to import the model, the scene, the whole scene. Okay. For that you create again a variable. You know how to do that. We can call it GLTF loader, and again new instance, but again not the error from 3, but it's from GLTF loader again, not from 3, so we don't get that error. GLTF loader, okay, and always a parenthesis to this. Since we have this variable, to get our model, we access the load method. With the load method, we load the path that we have this model scene. Okay, so GLTF loader dot load. Okay, the load method, and here is URL here. It will show an error, but just for the moment we will edit later. So the first parameter of the load method is the URL, and the second parameter is a function, and this function contains the GLTF model, okay, that we load. So we just write GLTF. You can name it anything, but GLTF, it's the model that we will use. An arrow function. Okay. And here we can manipulate and show the model. For that, we create a variable called model. Okay. And usually to get this scene from the model after loading is simple as gltf.scene. So this model that we have that has the parameter here, gltf.scene. Because if we go and console log that, we did it in the other videos. I go in depth with this. I try any kind of model in my other tutorials, so you can see if you want more in detail, or some understand things deeper, you can check those tutorials. But the simple idea is, usually you are lucky, you don't have problems or complex uh, structure of that model. Usually you can access it with gltf.scene, and you can import everything that it has, children's inside, etc., etc. Because the model have different meshes, animation slides, etc., etc. May have children's. This meshes might be different, etc. But usually you import everything with gltf.scene. Or in some cases you might need the loop, to loop through this children's that has inside. It depends. I show that in my other videos, so I'm not going to stop to this. So gltf.scene, and in the add scene.add, when you want to add something to the scene, is scene.add method, and as a parameter you put inside the model. Okay. We can also console log here the gltf if you prefer. Console log. Okay. But for now I will comment it, because we will do it later. Now we will get an error because we don't have any model, etc. We did this. The last thing that we need is because we are not rendering the scene now, and because we need to access the renderer to get the render method that has as parameters the scene and the camera. As we said, we have the scene, we have the camera. We need to check those screenshots. That for that is the render method. Okay. And for the render method, we put it inside. We usually create a function animate. Also for this, I talk about more in details in the other videos, but the idea is we create a function animate to animate between frames. On each frame, we animate the scene, so we don't lose anything. Okay, we may have an animation in the scene. Okay, we don't want we need to update the scene, to render the scene on each frame. Okay, since it depends on the computers, one computer is faster, one is slower, and it might change. It will show, for example, an animation faster on one computer, slower in another one. So we use a method for this to animate the things on the next frame uh, without having problems with one, or with the time between, etc. uh, we use window request animation frame. Okay, but I know it's confusing uh, explaining something without writing any code. Like, those are just words, and you just get confused. So my fault, I shouldn't talk. I should write the things and explain while I'm doing it. It's easier like this. Okay, so we have this function animate that will make it possible if we have animation, or we want to, not parentheses, we have animations, or we want to render the scene on each frame, so we can see the animation. And for this function here, we will do a recursive function. So recursively it will call itself with this request animation frame that I mentioned. Windows request animation frame. You can Google it. We do it in the other tutorials. But the idea is simple. It's recursively calling the function itself. Okay, so this request animation frame will call this, and this will call the animate again on the next frame. Okay, it will call the animate and it will start again the function. Okay, it will call the animate, it will start again the function on each frame. But we also need, as I said, the renderer, render.render, and the render method has two parameters: scene, we need the scene, and the camera to check the screenshot. So scene and the camera, so we can check the screenshots. We render the scene that we see. And now we have everything. We just need to call this function, of course, animate here. So it will call the function. It will start, it will render the scene in the camera, it will go here with the request animation frame, it will call again this function. It will start again. It will render the scene, it will call again recursively, okay? So it's like a loop. This is a loop to animate things. And this is the basic scene. Now we can go and use this GLTF loader to load our scene, the model that we have, and then we can create those camera movement and camera animation. Okay, but something that we can change here is about this request animation frame, because for VR projects, okay, we are using virtual tour, we have big scan of object. So for projects like VR, etc., we can use a built-in method for this animation loop thing to call the render on the next frame. And there is a built-in function that it's for VR projects. Okay, so this Windows request animation frame, it's for everything, but not for VR projects. So for VR projects, we can use the built-in method from the renderer, render.setAnimationLoop. Okay, this set animation loop again, so that we will call this animate function, but here we will delete this. Okay, we'll not call it recursively there, but we call it here outside. Render.setAnimationLoop, call this animate. It would render and so on. Here inside we can also update the controls later. And update the controls. We have controls, right? Controls, where is it? Yes, controls. That update. To update the controls. Also this, on next frame. What else? So we have everything for our scene. Let's check if we have any error. Okay, this the server stopped. We should run it again. npm run dev. Every time you want to run the server, you just need to npm I install at the beginning when you download the project to install all the dependencies, and then to run the server npm run dev, and you are good to go. Okay, do we have any error? Let's check. Okay, we don't have any errors. That's a good sign. So for the model, I have it here, the model. I want to show you something. On Sketchfab for cultural heritage, the largest platform to publish, 3D and everything. And there is a project, that all this, cultural heritage, like British Museum and all this, they have provided these modules for free, so we can use them. There are more than 2,000 3D models from, cultural heritage. There are very beautiful things here. As you can see, the British Museum, uh, Discovery Program, Santa Cruz. These are all. This is what we are going to use from Sweden. Science Museum, Universe. The Smithsonian has some models too. Okay, so there is this project by Sketchfab, and you can find everything from the cultural heritage. Okay, Digital Atlas of Ancient Life. You have everything here. If you want this page, I can leave it in description. Okay, you see, you have very beautiful things here. I like them because I use this. I am a fan of art, history, archaeologic sites, Museo Arqueológico Nacional. Look how beautiful they are. If you have in mind some, we can use maybe for our 3D art gallery, for the other tutorial. Yeah, we can use something maybe, you know, we can import these models. Yeah, why not? Look, Academia de Bellas Artes de San Fernando, Madrid, España. Look how beautiful they are, this. And they are good quality and they are provided for free. I think, yeah, most of them are free. I think all of them should be free because, as it showed here, for example, I have the Chateau de Versailles. I wanted to, yeah, I wanted to use this one at the beginning, La Galerie, or the Chambre de Roi, the King's Room. This is l'Opéra Royal, Le Grand Salon Jaune. I don't speak French, so don't laugh at me, but I speak a little bit, but I'm not. Okay, this one. This one is beautiful. Let's take a look. La Salle du Sacre. Okay, I'm entering inside. Look. Nice. Let's take a look. Yeah, this is Napoleon Bonaparte. Yeah, and this is his Josephine when she was a queen. Sacre de Napoleon and Couronnement de Josephine. Yes. And this is the Battle of Borodino, maybe. No, Borodino or Abu Bakr, or how it's called. Abu Kir, sorry. La bataille de la, le tableau de la bataille. And this is, I don't know. Okay, this is beautiful to use. What do you think? This is beautiful to use. As I said, you can make it interactive, something like this. You can show the description, and or for your business, you have an hotel, or I don't know, or restaurant. You move it around, show Of course, you should do the scans, 3D model, etc. But uh, the immersive experience here, it's very, very cool. Okay, enough. Maybe we should use this one or the one here. Where is it? Where is it? Where is it? Yeah, this one. The Holville Museum from, yeah, this one. Look at how beautiful these scans are. Look at this one. Like our gallery. Or maybe we can use this one. I like it. It looks very beautiful. Let's give it a look. Let's close this too much. Oh, this is very nice. This is great. This is great. Oh, we can use this maybe. Yeah, and take a look at the pictures. Like move the camera, present the user with here. And then information about the pictures. Look at the quality. Very beautiful. Yeah, we can import these things in our browser. You can make a website of this, guys. That is the beauty of Three.js and WebGL. Now browser, the future, I think the future of the web development is for everything actually is the 3D and the VR and HR. AR, not HR. I think about HR since. Okay, I really like this one. Okay, maybe we can download this one. I'll check a pause to drink some water. Okay, let's start and import this model in our scene and then play with the camera animation so we can finish our project. So go and download the model here, download 3D model, then go for GLTF format. We use GLTF when we work with Three.js to display and render a 3D model in the browser. GLTF or GLB, but yeah, go with GLTF. I'm not going to download, I think I have it already, so I won't let you wait. Great drawing room. No, I don't have this one. I have, okay, I have this one that I showed in a, yeah, this one is beautiful too. So yeah, let me see if I have it in my project. Static model Swedish. Yes, I already have it. Okay, I'm going with this one, guys. But yeah, you can download the one that you prefer. It will be the same thing. It doesn't matter which model you choose or another one that you might find. Actually, I did a research and I searched like everything about a museum or archaeological site, but I couldn't find a really good one. These were, let's say, the ones that were free here on Sketchfab, but also in other platforms I searched for. So yeah, these are the ones that are free actually, the good ones. I couldn't find anything better. But if you find something I don't know better that you want to use, go with that one. It doesn't matter. It will be the same. It will be the same thing. Okay, so I'll go here. I already have this GLTF loader that we had. So I'll explain this. we have this variable gltf loader from the class gltf loader here that we imported at the top. That is from three examples, JSM loaders and gltf loader. Okay, we create this variable. Then we use the load method, okay, from gltf loader. The load method has two parameters. One is the URL, the path of the module that we have it here in static module Swedish Royal. Okay, and the second parameter is a function. This function accepts this module as a parameter, this module that we load. Okay, then we console log it to see how it is structured, etc. Then create a variable for the module and give it the value of gltf.scene. Then add this module to the scene, scene.add module. Why gltf.scene? I will show you in the console log, because this model might have, inside these children's have different meshes, etc. So there are many things, animations, lights, I don't know, the quaternion on a rotation, many properties. So with gltf.scene, you import the whole scene. I will show you the structure of this module, and you will understand. Okay, let's see. Maybe we'll render it, because yeah, let's see. Maybe it is rendered in the scene since. Oh no, of course we have errors. The error get 3 module error fetch for this. Oh yeah, of course, because I didn't change the URL, I think. Yeah, of course. It's a fake URL. We don't have the path. Let's add the path here. And the path is static model Swedish Royal and then scene.gltf, the one that we need. So we don't type static here, but we go with model, then Swedish, right? Swedish Royal, and then scene.gltf, the one that we need. Scene.gltf, okay. And the path should be okay. Let's check. No errors. Oh, yes, of course. Encode in promise, reference error. GLTF is not defined. Why is not defined? Yes, I defined it here. Why is not defined? Oh, GLTF. Oh yeah, it's a typo. Of course, it's not defined because it's a typo. I have GLTF here, the correct spelling, and here it is GTLF. Okay, it's a typo, so that's why it's not defined. GLTF. Okay, I couldn't spot it. It should be okay. Let's hope no errors. I think no errors. Yes, no errors. We see the scene and we see the console log. Okay, before taking a look at the scene, let's take a look at the console log. Why this gltf.scene and what we are doing here. So we load with this method load the path here, the module in our local. Then it has a function that fires. This function takes this loaded scene, gltf. You can name it anything, but yeah, gltf. And then we create this module with the value gltf.scene. gltf.scene, because if you take a look, let's give the name here of this console log. Our model here. not dot, but comma. Okay. It takes a while to load because, yeah, it's a heavy scene. It's not very light. Our model, okay, our model doesn't matter this typo, but okay, our model here. So this is GLTF. GLTF is a group of objects, okay, and inside GLTF dot scene. And here we are, GLTF dot scene. You see inside scene has any kind of data, animation, matrix, position, quaternion, rotation, scale, uh, anything. And here, gltf dot scene, we render everything inside, okay? So our model is stored in this gltf dot scene that has everything inside. It depends. Sometimes you want to grab some children, sometimes you loop through these children, if you want to save animations or lights or rotation, it depends, it depends. But usually you just need gltf.c to render everything. And you should console log to make sure you have, for example, gltf, we are here, and then dot scene. If you see here dot scene, it should have children. Yeah, okay. Here the children, it's an object 3D. Inside these children, we should find the meshes. So gltf dot scene dot the children, and children inside has one array, and it's an object 3D. And this object 3D has inside all this again, this data, and has children, and this children has an array, one array inside. It's object 3D, and this one array has all this again animations, etc. And if we go here children, this children has 15 arrays that are meshes. Okay, so if you take a look, gltf dot scene dot children brackets 0, the index of 0, the first array, it's only one array, so dot children index 0, dot children again array index 0, dot children, we have 15 arrays. Okay, you see the structure of this. So that's why sometimes we loop with the for loop, or uh, depending, or with a while, or it depends. But if it's not a complex one, you should be okay with gltf.scene. It will render your scene. Okay, and that's it. Let's take a look at the model. It was loaded, we see here. Okay, it was loaded. Let's get inside. Okay, where we are, let's take a look from. Okay, here it is. Let's get inside. Oh, okay, we see it. Great. So here it is, our scene. I want to take a look what is the scale of this. Maybe change the scale. So the scale, gltf.scene. Rotation scale. The scale is 1. Okay. Well, the model is here. It is rendered. Okay. Now we can do our camera animation. Back to our code. For the camera animation, because yeah, it's hard to get it's hard to get these positions, with the code there, the exact position. For example, I want when the page starts, when the user clicks on my website, I don't want this position here. So the initial position, you know, I want it here, something like that. So the first time the user clicks the website, I want to show him a good view, not the one that we have. So we should change the initial position when the user clicks. But yeah, how to get this position here? We should do with the code, just guess or calculate, etc. So it takes a while to do that. It's hard to do that. So we can find another method. Maybe with this GUI here, we can add the camera here, the controls, and tweak the parameters in real time. Okay? So with this GUI, we can tweak the parameters in real time and get those values of the position. So we can set the position here. Okay? That is one method, way to do it. And to do it, we already have this GUI here, okay, but this should be inside the GLTF loader here. This should be inside. Okay, we can create this configurator, and with this configurator we can add the camera there, so we can tweak the parameter to get the exact, because we will need many positions to play with the camera, and it's very hard to get this exact position. For this configurator, we have a GUI from the little GUI that we imported at the top. Okay, then we can do something like access GUI dot add. Okay, and add this model. Model is our model here, this variable. Okay, the model position, because we want to tweak the parameters of the position. Okay, here we want to show the position, but also we need the rotation, because we want to get the position but also the rotation. So this is one method to do it. So model dot position. Okay, model dot position, comma, and you put here in strings as a value the axis that we want to check. So x. Okay, GUI.add model.position and x. Then we need some other values. For example, as you see here, you see the x and the 0. Okay, we can give some value to it. You see that it changes. Yeah, you see, we can give some value. But yeah, we want a slide. We want to make the slide. We want a minimum and the maximum value to tweak these parameters. So for that, model.position x dot, or let's do it like this, it's cleaner. Okay, dot min, that is the minimum. Okay, and for the minimum, let's give a value of negative. So from negative on the left and the positive on the right. So we have two. The minimum will be a negative number, okay, and the maximum will be a positive value. So for example, minus 100 and 100 positive. Okay, so minus 100. Okay, and again dot max 100. You can do it all in one line like this, okay? But it's cleaner for me to have it like this. Also, we can add another property of step. This is to have the accuracy, for example, how units we want to change between like 1, 2, 3, or maybe more exactly, like 0.01, for example. I want to be able, because if I move from one unit here, it will move a bit and it's not very, precise. So this step should be 0.01. When we slide the parameter, it will be from 0.01, 0.02, so it's more precise. What else? Do we need anything else? No, but we can, let's take a look. You see we have the slides here. Take a look how it moves. Okay, look at the camera. Look, this is what we need in real time, so we don't spend hours and hours to get the position of the camera with the code there. Yeah, you can get a headache. So here we have this slider here. X, let's give it also a name. We can give a name here. So that name, and here of course you can add the name. So model X axis, okay, to identify this. Okay, it's cleaner now. So the variable GUI from the class that we imported at the top, okay, then we access this add method that has the model position and another parameter of x, the axis that we want. Okay, and that's it. Take a look now. We have the name here that we identify, because below we might have, for example, rotation, etc. So model x axis, maybe position, which is that position, so we can identify the rotation, etc., etc. So model x axis position, uppercase. Okay, so we can identify these properties that we are tweaking here, the parameters. Okay, you see, it's way more easy. It's way more, look, you see? And then if, for example, if we want this position here, we can check the value here. It's minus 13, and we can change the position in our code. Put the value minus 13, okay? So we know exactly where it is. If not, we should, guess here, do calculations, take a look, debug, take a look again, change, and spend hours and hours. So the x-axis, the same thing, just copy this. I always say not copy, but these are the things that you copy, because it's the same thing. Change here y, okay. Again, the minus 100 and 100, the same thing. Change here the name and y, okay. So we get the position of the y-axis here. Let's check a look. Okay, so we have the x-axis. We can move it, we can play. Let's try the y-axis. Okay, we want it here in the middle. You see? Now I want also the z-axis, so I can enter, I can enter the gallery. And also we need the rotation. So I want to rotate this to have the model straight. We are getting there, but it's way easier than to do it manually in the code. So copy again for the z-axis. Okay, so here's z. It's the same, only this parameter here that changes x, y, and z, and this is just the name. Okay, now we have also a z. Great. Okay. The x should be here. The y we want it here, -5. And the z here, let's... Okay. This is why the step property here. To make it precise, maybe 0, 0. More precise, the values. Don't want the console log for now. Where's the problem? What is this? What happening here? what's happening there? 7.0. What have I changed? Nothing. Checkster? Why the checkster? Model material. It couldn't load the checkster. Why? Okay, I don't know what happened. I just restarted. Okay. So the x we want it here. The y we want it here. And you see, even like this, it's not so easy to get the, to get what you want. You see, even like this, it's not so easy to get the exact. Imagine, for example, if I want to go here, to have like very precise, even with this configurator here, it's not that easy, as you can see, to get the exact views I want to play with my camera animations. By the way, this module is very beautiful. Okay, so is there any other way to do this? Yes, there is. I will show you now. But you also have this idea how to create this configurator here. You can add the rotation here. You can change the color of the material, so you can add here not only the position, the rotation. You can add anything like changing the textures, changing the colors, changing the post processing of the model. So the designer, for example, you coded the project. uh, you can tell the designer, hey, I coded the configurator for you. You can make it look better, the project. Here you have the parameters. Work with it and change the colors, the lights. We also can add the configurator for the lights, the shadows, colors, the textures, or anything that you need. Okay, you can add this configurator everywhere. Okay, you can add everywhere and anything. So this is the idea. For now, I will comment out. I will leave it here so you have it on GitHub when I push it. But I will show you another way to do it, and it's better this way, because as you can see, it's hard also with the configurator for the position and for the rotation. For other things, it's a great way to do it. I will add an event listener. Okay, with this event listener, it's JavaScript. It's JavaScript. With this event listener, when I click here in the scene, I have the orbit controls. The orbit controls, I have it. Okay, as we said, the orbit controls are the controls to move around. Okay, zoom in, zoom out, and move around and rotate. So I have these orbit controls that I update here in the animate function. And so, having these orbit controls, I can add an event listener with JavaScript, that is the mouse up event listener. So every time I click, I listen for something. Okay, this event listener fires a function, and in this function, what I will fire the position of the camera. Okay, so I have the orbit controls. You see, I have it. Let's say when I start the the project, when the user clicks on the website, I wanted to show this view. Okay, let's say when I start the project, I want to start this view here. So I want the exact position of the camera here. And how to get it? We have this position because of the orbit controls. Okay, so with the event listener, I can click with the mouse up event listener. It will listen, and in the function I will add the position of the camera. Okay, so without confusing anyone, let's try it with the code. So here inside the GLTF loader, inside these curly brackets here of the load method, always here, I will add this event listener. So window, it's JavaScript, add event listener, parentheses. As I said, the first parameter is the name of the event listener, mouse up, mouse up. Okay, I think you already know this. And the function that will fire. Function. Okay. Inside this function, as I said, I want the position of the camera. So let's console log that. Console.log. And for the position of the camera, you know by now, camera.position. Okay. I also want the rotation because I may get the position, but I want a specific rotation too. So console log camera.rotation, as you know. Okay. So every time I click, this event listener will fire this function. And this function will console log the position of the camera and the position of the rotation of the camera. Okay, so we will get the values, the exact values, and they should be decimal, very precise. Let's take a look. Okay, so we said we use the orbit controls to go to the exact position that we want. So when the browser starts this project, I have it here. It's ugly. I don't want it here. I want another position. Maybe from above. You see here, I click the mouse here and I get all these values. We will we will inspect them together in a moment. Maybe here or from above. Yeah, maybe this view. When we first when we first open the project, the website, the user will see this view. So this is so when you are okay with it, you like this position, just click. When you click, you will get these values, vector3 and Euler. Euler we should talk about in another video about Euler, but it's about rotation. So if you know with math backgrounds, apart from x, y, and z, there is another one axis that it's W, it's Euler. And Euler is used uh, in 3D software programs because with a normal rotation we can get stuck in an axis. But yeah, we will talk about it in another video. So vector3 and the rotation. So for the position you will get these values of vector3. For the rotation you will get these values of Euler. So let's copy this. Okay, we copy this because if I refresh the page they will be gone. So just make sure to copy these values, and now if I change it will update and you will lose. But the initial position of the camera, you see the initial position here is 5, is just 5 on the z-axis, nothing on the x-axis, nothing in the y-axis. And that's why we see just that, view we don't want. So maybe I don't need this one here because I am rendering it here with render, scene, and camera. So let's, yeah, you don't need that scene.add camera. Let's change this position, the initial position of the camera. Oh, paste that comment. And here let's change it. Camera.position. Okay, that's set. When you want to set the all the 3 axes, if you want a specific one is camera.position.x, camera.position.y, etc. If you want to change all the 3 axes, camera.position.set, and with 3 values 0, 0, 0, or we will put these values here. You see they are very precise numbers. It's a decimal number with 20 numbers after. Okay, let's be this precise. Just we can change it later, only 4.9, but yeah, just try it precisely, or just get the first 2 numbers here in the y 4.4, and for the z 1.9. Okay, let's take a look. You see? Great. When we start the project, it will be in this position. You see? It looks nice, better now. Okay. We have the initial position. Now maybe we can work with the camera animation. And we can also add the rotation, the exact rotation here. Camera dot rotation dot set, and here in the Euler, the first two numbers. This is for the X, the Y, and the Z. Now we don't need any more these values. We start the project, we have this view. Good. Now, how to do the camera animation? Maybe I should. Okay, I'll leave it. I will do it later. I should also comment this. We will need again this mouse up, because this mouse up will make possible, as we did now for the first initial position, after the second click the project starts. After the second click we want to bring the user in another, we want to bring it in another view, for example here, guide him through this gallery. For example, the second, when he clicks for the second times, he will see this. Then he clicks again, we bring him in here, and so on. So we need this function. We need this function and this event listener for the mouse. But I also need this every time to console log. So what we will do, we will create as I said, I want to get the exact position and the exact rotation. So let's create two functions for changing the position and changing the rotation every time the user clicks or moves the mouse to bring him in this camera viewings, camera animations. We need two functions for this, as I said. One to call it camera move and another for camera rotation. Okay. So function. Are we outside? Okay, we are outside. Function. Camera move. Camera movement. Okay. And camera rotation. Function. Camera rotation. So it has the parameters here. We will pass the parameters of the three coordinates, the three axes, X, Y, and Z. Inside, we will use another library for this camera animation. And this library, you need to install it, npm Open another window, npm JSAP, npm I. It will install this library. Okay. Okay, it's here. After installing this, we need to import it at the top. Okay, import JSAP from JSAP. So for the camera movement, JSAP to method. JSAP has this method. So move to what? To this position. To get a position, we get it with camera.position. So JSAP2 camera.position. Camera.position. So move it to this position, literally. This is the first parameter of this method too, from JSAP. It has another parameter. It's an object with these properties. And the properties are x, y, and z, the parameters that we passed here. So x, y, and z. Okay. Another parameter will be the duration of this animation. For example, we move it, we will the duration, 5 seconds, etc. 5 is just okay, or less. 3 duration. Okay, 3, just 3 or 4 or 5. You can play with it. The same thing with camera rotation. Okay, JSAP dot to this method of JSAP that has these parameters of 2 to camera rotation. Change the camera rotation. Camera.rotation. Take a look, not this rotate on axis, but rotation. Okay, and the object for x, for y, for z, and it was the duration. Duration, again 3 or 4 for the rotation, doesn't matter, 3 again. We will play maybe later with it. Okay, so we have camera movement and camera rotation. Every time the user will click in a page, we will bring him to these positions that we want. That might be 2, 3, 4, 5, or 10, depending on the tour that you want to show him, because we are showing him a virtual tour. We have these two functions, so now we can use them. Let me take a look if I have any error or anything. I don't think we have any error. No, we don't have any error. And here, comment this. Okay. Actually, what I will do is I need this one just to test. So I need just to test, but also I needed to set these positions. So I will just create a new one here. Just, this is to change and this is to test. Add event listener. Don't get confused. You will see. Mouse up. And then function. Okay, we have this event listener. and we'll fire this function. For this, I want to make 2 or 3 or 4 animations. So click the first time, we will bring him with the view that we want. Click again or move the mouse again, we will bring him in another view. Click again, we will bring him forward or whatever. So we need like 3 or 4 depending on you. So we can do that with an if statement or with the very clean code with a switch case. Okay, so case 1, case 2, etc. And we will create this. Let's see with the code. It's always easier to understand when you explain the things while coding. So we'll create a switch case here. Switch, okay. This switch case. Okay. Will be the case 0, case 1, case 2, case 3, etc. etc. Case 0. Okay. For this case 0, we will use this function to change the position first. It's camera movement. Camera movement. And we will give here the parameters that we want. Okay. Here it accepts the x, the y, and the z axis. Okay, with a duration of 3. So we will pass this function, call it here, with the values that we want to change. With the values that we want to change. What values? We don't know because we will get the exact position while testing in the browser, while using the orbit controls and this console logs. Okay, that's why I made 2 of this. Okay, because I don't know where I want the user to the position of the user here, because I don't know. I will get it while debugging with this console logs. For now, just leave it 0, 0, 0. Just to create, I just want to create this switch cases. Later we will change it. Okay. So the first will be the movement with this function, and the second will be the camera rotation. Camera rotation. The same thing. I don't know the rotation for now, so let's give some default values. Okay. But this switch case will have an initial position. Okay, so let's create a variable here, let position, let not const, because this position will change, let position, and the value of 0, just a false value initially. So when it will start initially, it will be the initial value case. So switch position, this. Okay. After the rotation, we want to set this position from 0. We want to set it to position 1. Okay, and we'll go in the next case. Okay, and the next case, changing from 1 position to 2, position to 3, etc. So this is the first case, and it is done. Always don't forget when you use the switch case. Don't forget. Sometimes I forget the break. It's normal to forget. So at the break, at the end of every case. After this break, we have the second case, which is case 1. Okay. Again, for this case 1, I will add the camera movement and camera rotation functions with the second tour we want the user to. So camera movement, default values 0, 0, 0. Camera rotation, default values 0, 0, 0. Okay. In this case, the position will be equal to position equal to, and then break again, and so on for all the cases that you might need. Okay, so case 0, case 1, let's add one or two. So case 2, let's copy this one and here change the position to 3. Okay, and break, and so on for what you need. Okay, I will comment it for now because I want to test. So let position 0, some position, yeah, it should be okay, yes. Comment out for the moment, and let's get where I want the second position to make the animation. Okay. The project starts at this initial position that we set it here at the top. Okay. Initial position. Okay. Now I want to change it when the user clicks. You see, we get the values. I want to change it to I don't know. Let's try. To this view, maybe? Yeah. Get this one. Click, and you get these values. You console log this. Copy the vector 3 and the Euler. And let's test it here. Don't get confused from all this code here. When you have it on your computer, it will be easier for you because I scroll down, up and down, and it might be confusing. But we are inside this gltf loader.load doing these things, okay? Only the functions are outside this gltf loader. Are the function outside? No, the function are not outside. You see? Okay, get these functions outside. Okay. The functions, we can put it outside. Let's delete this configurator for now so we don't get confused. We don't need it. We are testing the positions with this. We are console logging with this event listener. It's the same as this one, but I just commented for now. So just to test, copy it again because I didn't have it anymore. Okay, I want this position, the second one. Looks good, this view here. Okay. Click and get the values. Okay. So for the first case, let's change the camera movement. You see, with the camera movement, we pass these parameters x, y, z. JSAP2, we will change to this position. So we call it here with these new values. So let's grab the first three. Okay, the first three numbers for the x, the y, and the z. Oh, I copied the Euler. Oh, you see, I copied the Euler. No, I want the position. My fault. Let's divide. So the x is this one, the y this one, and the z. Only the first three numbers. And for the rotation, the x this one, okay. Don't need them anymore for now. Comment this one that we are doing the test. Comment these other two cases. Let's see what happens if I have any error or anything. Connection refused. Why? What's happening here? Connection refused. I don't have connection here. npm run dev to run again the server. Okay, no problems. It was just the server stopped. Let's try. If I clicked, it should bring me to that other view. Let's see if it works. Click. Yes, it works. Oh, it changed the position, but it didn't change the rotation. Hmm. You see? It changed the position, but it didn't change the rotation. Was the rotation correct? Why? Let's add another one. Test again. The third view will be doesn't let me. So yeah, just to try another position. Come on. Okay. Click and get these values. So the same thing. Get the values of the x positions, and this is for the case 1. Now the rotation. Initially position is 0, position 1, position 2, position 3. Let's try another position. We were here, so Again, grab these values. Return to 0 again. Let's just test it. Click. Code reference error. X is not defined at camera rotation. Yeah, it was an error at the camera rotation. That's why X is not defined. Let's see why it's not defined. Oh yeah. Oh, okay. Okay. I got it. The error. They are all not defined. The X, the Y, the Z, because I didn't pass the parameters here. X, Y, Z. Okay. Because when we call this function here, it should it should know what parameters we are, what arguments we are passing here. Okay, so I didn't define, so x, y, z. Let's try again. Click. Okay, it works. We should clicks. This is the second case. It works. We should make the better position, but you see we will return again in this very strange position after every animation. We should debug this. Click again. Okay, the third animation. It works. Okay, with better precise position maybe, but the problem is that every time I click it, in each case I return to this strange position. It should stop there. For example, it should stop there. If I don't click, it should stop there. And we have a bug here. We need to debug it and solve it. But yeah, it works. That event listener and the function that fires, it works. As you see, it makes all this animation. Okay, I'm just testing it, but you can make more precise positions. You just do that work with console logs, click, get the values, put the values there, make 5, 10, 20 cases as you wish. It doesn't matter. For example, I have it, it doesn't matter, but the idea is that one. Or make not very long flights, just go from here and take a look how you move without doing all rotation. But yeah, let's try and fix this bug that it returns to this position. I think I have an idea why it is doing this strange behavior, but let me first, I think I have an idea. Yes, I have the idea why it does this. Is it everything correct here? Position 0. If position, case 1, do this movement, position is 1, then break. Then do this movement, position equal to 2, then break. Do this movement, position is equal to 0 again. This is correct. The function, why this z isn't used? Seems like it isn't used. Oh yeah, I see another bug here. You see, because it's gray. It shouldn't be gray. That's why I spotted, because I couldn't spot like this one, and it doesn't log in the error, so I couldn't spot this one. I spotted because I saw this parameter here, great, and when it is not used, the parameters are like, has these shadows, like they are great. Okay, when they are used, they have the color, the full color, they shine. So I spot this error because it is great here, and you see x, y, x should be z here. You see they are all shiny because I'm using it. Okay, but this is not the bug why we had that strange behavior turning the position, but it was another bug, because we will have it again. You see, I return to that position, change again to the second, it will return. You see, change again to the third tour, it will return. So we need to fix this one, and I think I know why. Because we have the orbit controls activated in our animation loop. So I needed these orbit controls because with orbit controls we got those uh, precise positions. But you see here I'm updating the orbit controls in the animation loop, so that's why I think. But yeah, for sure this is the reason. If I comment this, let's check now. uh, I don't need this for now, since I need it just to use. I don't want the user to move inside. I want to guide the user. Okay, so I want to guide in a tour in the positions that I want him to bring. Okay, so I deactivate these orbit controls. Let's try now. It should be okay. The first position is this one, the initial position. We click. Okay, it goes here. Oh yeah, it looks nice. It was the problem of the X, that I corrected the typo. So it looks perfectly fine. Click again. Ooh, this rotation, okay, but it works. We should fix that one, because we should use from that position, okay, we can fix it, but it doesn't matter. The idea is this. So it stays in this position. doesn't return, and with that strange behavior. So the bug was fixed. That was the bug. The orbit controls, try again. We are in this new position and it stays. So the bug is fixed. The bug was here. So if you get this strange behavior, make sure to remove the controls update after you used it. Okay, that is a bug. And it works. This is, guys, the project. I think I can finish here the tutorial. You can add you can add more cases here, switch cases 10, 20. If you have a bigger scene, you can bring everywhere with this method. Okay, use the orbit controls to navigate in your scene. Use the orbit controls, get the exact position with the event listener, mouse up. After getting the exact position, make the switch cases here 1, 2, 3, 10, 20, etc. etc. depending on your needs and your project. But yeah, this is the idea. I hope you enjoyed this tutorial and learned something. Or I always uh, am thinking about the beginners here because so I will see you in the next tutorial. Okay.